Hello friends. This video is brought to you by mywayteaching.com.
Let us conduct an experiment to understand conversion of solid from one shape to another. Take a candle in shape of a solid cylinder, melt it and pour whole of the molten wax into another container in shape of a sphere. On cooling, we obtain a candle in shape of a sphere. Volume of new candle so formed will be equal to the volume of earlier candle, that is the cylindrical candle. So we need to remember that when we come across objects which are converted from one shape to another, or when a liquid is poured from one container to another, the volume doesn't change. To understand what has been discussed, let us take up this example. A cone of height 24 cm and radius of base 6 cm is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. In this question, we are given radius and height of the cone. Let us recall that volume of the cone is given by 1/3 pi r square h. If we substitute here, we get 1/3 into pi into 6 into 6 into height, which is 24 centimeter cube, which is the volume. Now this has been reshaped into a sphere. Let us assume that radius of the sphere is given by r. Then volume of the sphere will be given by 4/3 pi capital R cube, and the two volumes, that is volume of the cone and volume of the sphere, should be equal. Let us equate and solve them to find the value of radius of the sphere. Pi gets cancelled, 1/3 gets cancelled, and we are left with r cube equal to 3 into 3 into 24, which is equal to 3 cube into 2 cube. So radius of the sphere is equal to cube root of 3 cube into 2 cube, which is equal to 3 into 2, that is 6. So the radius of the sphere is 6 centimeters. Let us read the question. Selvi's house has an overhead tank in shape of a cylinder. This is filled by a pumping water from an underground tank which is in shape of a cuboid. The underground tank has dimensions 1.57 meters, 1.44 meters and 95 centimeters. The overhead tank has its radius 60 centimeters and height 95 centimeters. Find the height of water left in the sump. After the overhead tank has been completely filled with water from the sump, which had been full. Compare the capacity of the tank with that of the sump. From the question, we understand that our sump is bigger than the overhead tank, and volume of water in overhead tank is equal to volume of water that has been pumped out from the sump or removed from the sump. Now volume of water in the overhead tank can be given by pi r square h We can substitute the values. After converting centimeters to meters, we get radius equal to 0.6 and height equal to 0.95. Similarly, we can calculate the volume of sump, that is the underground tank, which will be given by length into breadth into height, which is equal to 1.57 into 1.44 into 0.95 meter cube after converting height into meters. Now the volume of water left in the sump after filling this overhead tank will be volume of the sump minus volume of the water in the overhead tank. Let us substitute the values. Volume of sump is 1.57 into 1.44 into 0.95 minus volume of the overhead tank is 3.14 into 0.6 into 0.6 into 0.95. Let us solve this further. We have 1.57 into 1.44 can be written as 0.36 into 4 into 0.95 minus 3.14 can be written as 1.57 into 2. 0.6 into 0.6 is 0.36 into 0.95 as it is. Now we can take out 1.57 common, 0.36 common, 0.95 common, and we are left with 4 minus 2 in the brackets. Hence we have 1.57 into 0.36 into 0.95 into 2. That means this much cubic meters of water remains in the sump after the overhead tank has been filled. Since we have to find the height of water left in the sump after the overhead tank has been filled, that means we have to find height of the small cuboid which is left behind, which the water occupies and whose volume we have calculated. Let us equate this volume to length into breadth into height of this blue cuboid or the cuboid formed by the water which is left in the tank. So we have height of the water left in the sump equal to volume of the water left in the sump by length into breadth of this cuboid formed, which is equal to volume of water by 1.57 into 1.44. Solve this further. 1.57 gets cancelled. 0.36 4 times gives us 1.44. On solving this we get 0.475 meters is the height of water that is remaining in the sump. Now, according to the question, we also need to compare the capacity of the tank with that of the sump. So let us take the ratio. We already have volume of the tank, which is 3.14 into 0.6 into 0.6 into 0.95, and volume of the sum is 1.57 into 1.44 into 0.95, which gives us ratio equal to 1/2. Therefore, the capacity of the tank is half the capacity of the sum.